All right, so now we're going to talk about another type of discrete probability distribution, and that is a binomial distribution. So it must, for something to be a binomial, it's got to satisfy four criteria, plus it's also important to understand exactly what the variable is. So even though I have these numbered 1 through 5, when we go through and start checking whether something is or isn't a binomial, we're really going to focus on these top four. So the procedure must have a fixed number of trials. I'm going to put a big old F here because we're going to do something to help us remember these. The trials must be independent. Each trial must have two outcomes, either success or failure. Finally, I quit with my letters. So independent, we're going to put I. Two outcomes, we're going to put T. And the probability of success must remain the same. So same probability each time. A nice way to remember this is FITS. Fixed trials, independent, two outcomes, same probability each time. We're going to define the random number variable x as the number of successes. So we're going to look at a couple different situations and we're going to see whether it fits the binomial situation. The first thing we're going to say is, so the first one is roll a 12-sided die 8 times and record whether or not a 10 was rolled. So fixed trials. Is it? Well, we roll the die 8 times. What we're going to use is we're going to use n equals 8. Next thing, are they independent? Well, you're rolling a die, right? So yes, this would be independent. Are there two outcomes? Are there two outcomes? When you think about this, there are 12 sides to this die, but we've determined whether or not a 10 was rolled, so it's going to be either yes, a 10, or not a 10. So that is two outcomes, right? So that's a yes. And then is it the same probability each time? The answer is yes. And we're going to use the letter P to indicate the probability of rolling a 10. There are 12 sides to this die. Probability to roll a 10 is 1 out of 12. So this one would be yes, this is a binomial distribution. Survey 10 random adults. Do you regularly watch the 6:30 evening news? Let's go with fixed trials. I think the answer is yes. There are 10 trials. Are they independent? Yes. Again, one person watching the news doesn't have anything or any effect on the other person. Are there two outcomes? Yes. You either watch the news or you don't. And is it the same probability? Yeah, there's a group of people who watch the news, and we don't know what that percentage is, but it's not going to change, so that's going to be yes as well. So this is going to be yes. All right, the next one says survey 10 adults. Which news do you prefer? ABC or CBS, ABC, NBC, CNN, or Fox? So for the fixed trials, we're going to say yes. Again, N is 10. The independent, yes. How about the two outcomes? This one's a no, right? There are more than two outcomes. There are 1, 2, 3, 4, 5 different outcomes. So we would say not binomial, or not a binomial probability distribution. The next one's a little trickier. 3-color spinner. Count the number of times it takes to get red 5 times. Think about this one. I'm going to give you a few seconds. Hit pause on the video. Why don't you think about whether or not it's a probability distribution? Well, in terms of a fixed number of trials, do I know how many times I'm going to spin the die? Or use the spinner? I might need to spin it 5 times. I might get red all 5 times. I might need to spin it 15 times. So this would be no, it's not binomial, because there are not a fixed number of trials. How about the next one? Record the weights of 7 newborn babies on a particular day at a hospital. I really highly doubt that 2 babies are going to weigh the same thing. So since I'm just taking their weights and recording them, this is going to be no as well, because there are more than 2 outcomes. It's really important that you just don't write yes or no on these problems when you need to take a test or a quiz. I really need you to spell out why it is or it isn't. All right, this next one says, quality control personnel at the light bulb factory picked a random sample of 25 light bulbs and recorded the results of each bulb. So let's go through this. Fixed trials. Yes. N would be what? N would be 25 light bulbs. Independent. Now, I know it kind of seems like maybe we're sampling without replacement, but we've talked about this in a previous video, that as that sample size grows and grows and grows, even though something may not be a dependent event, we treat it as it may not be an independent event. We treat it as it is, because if I take one out, it's really not going to affect the probability. So we're going to say yes here. 2 outcomes? Yes. It either works or it doesn't. And then finally, same probability each time. Again, we said we were going to treat this like an independent, and there are a certain percentage of them that are working or not working, so I think we're going to go with yes here as well. Next one, survey 1,000 kids. What's your favorite color? I don't know why it says was rolled here. I think that was from the previous problem up here, the first one. Survey 10 kids. What's your favorite color? I don't think this would be a no. And why is that? It's because there are more than 2 colors, right? Or more than 2 outcomes. All right, and I think we have one more down here. Let me find it. Sorry about that. I found that example. It was spaced down a little bit. So there are 10 red marbles, 5 blue marbles in a sack. 15 people each draw 1 marble from the sack, and the results are recorded. Let's think about this. I want you to think about this one a little bit. Does this have a fixed number of trials? I think so. But are they independent? I think this is a case where, I'm going to scroll down a little bit. People love when I write this, but actually we're going to say it depends. And again, I would never do this on a test or a quiz, but what you want to do is, what does it depend on? Let's go through. If we do this with replacement, if I put the marbles back in the bag, there are a fixed number of trials. There are 15. They are independent, right, because I'm putting the marbles back in. There are 2 outcomes, right? You're either getting red or blue. And it is the same probability every time because you're putting the marbles back. So if it is with replacement, the answer is yes. If it's without, then the answer is no. And why? Fixed trials. There are still the fixed trials. Are they independent? No. So this would be an X for no. There are still 2 outcomes, red or blue, but the probability will not remain the same each time because you're taking the marbles out of it. So we're going to go through this a couple more times with other binomial situations, but it's really important to understand when you can and when you can't use a binomial formula or binomial distribution.